Hi, Math 8. First of all, let me just tell you that you're going to want to pause this video in about 10 seconds so that you can write the title along with this diagram and just this pink writing, okay? So do your best to draw it nicely, neatly, take your time. So you might want to pause right about now. Okay, so now that you've written down all of that, let me explain it. We have, all numbers fall under real numbers, but then they fall into two groups. We have rational numbers and irrational numbers. Really quickly, natural numbers are 1, 2, 3, 4, so on, okay? And then whole numbers include the number 0, so it's 0, 1, 2, 3, 4, 5. Integers are the negatives and the positives of the math world. So then we have 1, -1, 2, -2, 3, -3. Okay, and then rational numbers include all of these natural, whole, and integer numbers, but along with all the numbers that fall in between wholes, like half, 6/10, 3 3/4. And they are considered rational because they can be written as A over B. Now, what does that mean? Let me just give you two quick examples. 10 over 5. Now, it's a fraction, but it's also a division problem. And 10 over 5 equals 2. So 10 over 5 is a rational because it can eventually equal 2. Now I'm going to write the reciprocal of this. Okay, 5 over 10. Now 5 over 10, if we simplify it, is 1 over 2. See, A over B equals A over B, but they're equal. And so that falls under rational. Now what are irrational numbers? Well, irrational numbers are things that can't be written as A over B. For instance, the square root of 2 is irrational because 2 is not a perfect square, okay? For instance, the negative square root of 6, okay? Now, why are these over here? Why is 6 pi and pi over here? Well, these are irrational because they are non-terminating and non-repeating. And what does that mean? Well, if I take my calculator, and if you could look this up on the internet if you'd like, if I push pi, look at that value, all right? 3 and, well, I hate to say point, but I will, 3.141592654. It's a non-terminating. The only reason it ends here is because my screen isn't that wide. It doesn't repeat. You know, let's find a number. Oh, here's 1. 1 is followed by 4. Here's a 1 again. It's followed by 5. Here's 5, it's followed by 9. Here's another 5, and it's followed by 4. So it doesn't repeat, okay? And that's what's considered irrational. Let's talk about classifying real numbers as rational or irrational. This is pronounced correctly as 35/100ths. So if you take 35/100ths and you change it to a fraction, it's 35 over 100. And then let's factor that out. So that's 7 times 5 over 20 times 5. 5 over 5 simplifies to 1. And so 35/100ths can be written as 7/20ths. So this is considered rational because it can be written as A over B. Now let's talk about B, okay? The square root of 15. Well, let's think about the square root of 15. Well, actually, let's think about some various squares right now. Let's see. The square root of 9 is 3. And then the square root of 16 is 4. 9 is a square number. 16 is a square number. The roots of these, right, are right there. So then 15, the square root of 15, is irrational because it is not a perfect square. Actually, I forgot to put this right here. This is considered rational. Okay?